Let's see what else this was good for.
Voltage across R3 and R5.
What's the nodal voltage? Can I do that? Yeah. Because I've got my current across here. This is electrically the same point as it is there. So if I go from here to here, that'll tell me my nodal voltage. So I need the voltage drop of R3 and R5. So what are they?
660 millivolts.
And
1.1 volts.
so my nodal voltage would be
1.76 volts.
1.76 volts plus. Which direction is current going? Away from the node, right? So is it going to be positive 1.76 volts or negative? Negative. Exactly. Did I do the nodal analysis technique? No. Did I find the voltage node? Yes. Do we get it? Any questions? Let's look at something else now. So we could be asked to find the current through there, right? The current around that corner. We could be asked to find nodal voltage. We know how it would apply. And it's true. It's true. What if the question were, what's Millman voltage? Let's go ahead and set up for Millman. Let's go ahead and set up for Millman. For Millman, we need voltage over resistance over the conductance, right? Or 1 over the resistance. So, voltage Millman equals, what do we got for this branch? What's the voltage? 15 or negative 15? It's going to be negative 15 because the negative terminal's up. Over what resistance? 3K. What about this branch? 15 volts over 4K. What about this branch? 0. Okay, now I do the conductances in the denominator, right? 1 over 3K plus 1 over 4K plus 1 over 8K. Okay? Negative 15 volts divided by 3K is going to give me what? Negative 5 milli. Plus 15 volts over 4K. 3.75 milli. All of that over 1 over 3K. Plus 1 over 4K. Plus 1 over 8K. All right, let's add them up. This side do the denominator, this side do the numerator. What do you get in the numerator? 1.25 milli? Negative?
Yes.
And what do you get in the denominator? Okay, take negative 1.25 million divided by 708.33 micro. What do you get?
Negative 1.76.
Negative 1.76 volts. Is that not the same thing that we got for our nodal voltage?
Yes.
Is that not the same thing that we were able to determine using Thevenin's theorem? Yes, question?
Yes, I have a question about when we did Thevenin's. We found out the nodal voltage was negative 1.76. Explain
We did
that.
not find that out. What did we find out when we used Thevenin's?
We used that to determine the voltage drops across those resistors. And
Correct.
we
But
found-
what did we first find out about Thevenin's? What did Thevenin's lead us to?
The
The current. We found the current across this branch, right? Once we were able to find the current across that branch, or the current, what did I say? The current up here, right? So we found the current across that branch, that which allowed us to find what? The voltage drops. And then we said, okay, well, that's the same thing as finding, if these are the voltage drops here, that wouldn't be any different than finding the nodal voltage right here, right? Except we need to ensure that we're following the polarity issue, right? So what did we say, or what did we look for at that point? What direction was current going in this branch? It was going down away from the node, right? Remember, it was going down? And if it was going down, then this side of the resistor is the negative side, meaning that that voltage at the node will be negative. And we just verified it using millimeters. Does that make sense?